we move to the next question.
Okay. State 3 characteristics of homologous series.
State 3 characteristics of homologous series. From the word homologous, homologs. Homologs, they are substances that share the same characteristic. Homologous series. Now, in homologous series, we have gradation in the difference between a succeeding member and a preceding member. Chemistry students, you know the alkane families. Alkane, alkyne. The first member of the alkane family is methane. Methane is the first member. And the formula is CH4, followed by ethane. And the formula is C2H6. It is of no more news to you that when you want to start the alkane family, you don't start with methane, nothing like methane. It is ethene that is the first member of the alkene. Likewise, the first member of the alkyne is also ethine. Now, homologous series. If you look at CH4 and C2H6, which are homologs, you will notice a difference of CH2 between them. Because this is we have one C here, we have two C here. 2 minus 1, this is 1. We have 6 hydrogen, we have 4 here. 6 minus 4, 2. Meaning that homologous series are family of organic compounds in which a succeeding member differs from the preceding member by a difference of what? CH2, which is called methylene. This is methylene. Or you can still better define it as a family of organic compounds in which a member differs from the one next to it by atomic mass of 14 AMU, 14 AMU, atomic mass units. Now, to substantiate this, the latter definition is that carbon has, what is the atomic mass of carbon? 12. What is the atomic mass of hydrogen? 1. And we have 2 hydrogen here. 2 times 1, that is 2. 2 plus 12, this is 14. A member is different from the one next to it by what? Methylene group, or by atomic mass of 14 AMU, 14 atomic mass units. Now, in this homologous series, members, like I said, they show gradation in properties as regards their physical properties. As the lower members with lower molecular weight, these ones are gases. Up to butane. Butane is also a gas. But when you get to pentane, which is number 5, that is number 5, pentane. Pentane, that's a C5H12. H12, it is not by magic I'm getting these molecular formulas. They conform, all of them conform to the same general formula, which is CnH2n plus 2. This is for alkanes. Alkanes. If you put for the first one we did, it has 1 carbon. This is 1 carbon. Then the N is 1. If the N here is 1, 2 times 1, that's 2 plus 2, 4. That is why CH4. The same applies to the rest of them. Okay, in physical properties, they show gradation in the sense that the first members are gases. Those ones between from pentane to up to carbon 17, they are liquid. meaning that those ones that are in the middle of the series are liquid, while those ones of higher molecular weight are solid. They are what? Those ones are solid. This is what I mean by gradation in their property. If you look at them again, in their physical properties like melting point, boiling point, density, all these properties, they increase progressively as you move down the group. Meaning that those ones that are the first members, they are gases and they have low density. If you calculate the density of this one will give you 16. 16, carbon 12, 4, 16. This is 24 plus 6, 30. You can see the density is increasing as you are moving from one member to the other down the group. So also is their melting point. Also it increases down the group in the series, but they have similar chemical properties. Take note, they show gradation in their physical properties while they have similar chemical properties because they belong to the same family. They are members of the same family. And we do know we have the same glands in a family. When we call something family, even in a population, the same glands. Now, these are the characteristics of homologous series. Can we proceed to the next question?
Give the name and structural formula of the second member of the alkyne series.
Thank you very much. I introduced that. What was I taking? Why taking the members? That I said the first member of the alkene and the alkyne, they are never methyl and methyl respectively. They are not. They are rather what? They are rather ethene and ethyl respectively. The first member. Now, the second member asked in the question, that is propane, which corresponds to the third member of the alkanes. Now, straight away, the second member is propane. Propane. I would like us to do it together. Second, this is propane. And propane has, that is number 3. You will go by the alkane. That is number 3. Propane now has 3 carbons. Use this formula for it. Instead of +2 for alkane, it is -2 for alkyne. Why you don't have any addition, be it minus or plus for alkene? This is for alkyne. The second member, like it is said, that's second member.
Yes.
Now, the second member now is carbon 3. So we need to take note of this. We will now substitute these 3 into this equation. 2 times 3. This is 2 times 3. It will give us 6 minus 2. 6 minus 2. Meaning that we have 4 hydrogen. C3H4. The question asks us to calculate, to show structural formula. Some of you put down the molecular formula. This is the molecular formula. The structure, you need to show the carbon joined by covalent bond, like this. Then show the attachment of the hydrogen. Now, the identification, how we identify alkyne is by triple bond. It has triple bond, which I put between 2 adjacent carbons here. How do I place the 4 hydrogen? Hydrogen here, hydrogen here, hydrogen here. Then I have hydrogen here. This structure has in excess 2 bonds when compared with the corresponding alkene. it has two bonds in excess. And then because of these two bonds in excess, the two carbons in which between which we have the triple bond, they are going to lose hydrogen. Normally, this one has 3 hydrogen, but it is enjoying 2 bonds in excess, meaning that it will be short of 2 hydrogen when compared with this one. This one not has 2 hydrogen, and the 2 hydrogens are no more there because it is enjoying 2 bonds in excess. Now it has to this one, the 2 carbons, they have to sacrifice for the gain of 2 bonds. This is the structural formula of propane. This is propane, which is the second member of the alkyne family. Hope it's understood. Now let's move to the next question. Molecular formula, structural formula. Molecular formula, structural formula. The next.
Write an equation to represent the combustion of ethene in excess oxygen.
Ethane in excess oxygen. Can you see? Ethane is an alkane. An alkane, CnH2n plus 2. And it is the second member. Now, the n becomes 2. Then we have 2 times 2 plus 2, which is 6. I have H6. Okay? I have correctly calculated the molecular formula. Oxygen combustion. When something reacts with oxygen, the products are carbon dioxide and water are the products. These are the products. The equation is as simple as this. What we need to do now is to balance the equation. How do we balance? We can balance by trial and error. But there is one formula for balancing alkane, combustion of alkane families. And the formula is simply, when you have this, the alkane, CSHY plus, this is oxygen, plus X plus Y over 4 oxygen. This is the number of oxygen you have. Then we are going to have X carbon 4 oxide plus Y over 2 water molecule. This is how you can get this. Looking at this now, carbon atoms. 2 carbon atoms. Just simply write C2 HY. This is HY. H6 plus our X. X here is 2. I have 2 plus Y over 4. Y over 4 is 6 over 4. Then this is my oxygen. I have X carbon dioxide. X carbon dioxide. This is X. Means that I have 2 carbon dioxide plus Y over 2 water molecule. This is Y, 6. That is 3. 6 divided by 2. Okay, let me write it as 6 over 2. H2O. Now, let's try to solve this. This one remains C2H6 plus this. This one will give us 3 over 2. That is 1.5. Is that not 1.5? Plus this 3.5. So now give us 3.5, which is 7 over 2. Now correct. What you can do now is that 4. This is 4, which is the LCM. When you do this, this one will become 3 over 2. and 3 over 2, 2 in 3, 1. Then remainder 1 over 2, that's 1 and a half. 1 and a half added to 2 will give us 3 and a half. When we take the 3 and a half to improper fraction, we are going to have 7 over 2 here. Oxygen. 7 over 2 oxygen. To give us 2CO2 plus 3H2O. 3H2O. If you remember your law of multiple proportion, reactants, substances, atoms, they combine in simple whole number ratio. They do not combine in fraction or decimal like this. We need to do something to this. And what we will do is that we can multiply this equation by 2 to nullify these 2. You know, when we say 7 over 2 times 2, these 2 will cancel these 2. We will not have fraction again. The 2 will now affect all of them. We now have 2C2H6 plus 7O2. The 2 has gone like that. This one has nullified it. This one will now give us 4CO2 plus 6H2O. This is a balanced chemical equation for the combustion of ethane in oxygen to give us carbon dioxide and water as products. If we check 2 times 2 for carbon, I have 4 carbons here. 2 times 6 for hydrogen, I should have 12 hydrogen. 6 times 2, 12. I have 40 oxygen. 4 times 2, 8, plus 6. This 6 affects, the equation is balanced. That is a balanced chemical equation for combustion of ethane. Next in the list.
Name the type of reaction involved in the conversion of ethanol to 1-ethene.
Please hold on a bit. We want to convert ethanol to what?
Ethene.
Ethanol to ethene. Okay?
Then secondly, ethyl ethanoate.
To ethyl ethanoate, it is the same ethanol we are converting. Ethyl ethanoate. Okay?
Then the third one, chloroethane.
Chloroethane. Go on.
Then the next one is ethoxide.
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 Very good. Ethoxide. Ethoxide.
Then what? The last one, ethanoic acid.
Last one, ethanoic acid. Good. When you convert ethanol to ethene, this one is termed dehydration. This is dehydration. I will illustrate it. This is dehydration. Removal of water from a substance in which the chemical nature of that substance changes as a result of that. When you have, this is ethanol. Ethanol is C2H5OH. Now it becomes ethene, C2H4. Water is removed. It is called dehydration. The next one, ethanol to ethyl ethanoate. This one is called esterification. Esterification, ester formation, esterification. Okay, this is esterification. How do we show esterification? It's a reaction between ethanol and an acid. In this case, an organic acid. An organic acid, say ethanoic acid. CH3COOH. Through a reversible reaction, For us to get ethyl ethanate, this ethyl ethanate CH3COOC2H5 plus water. Ethyl ethanate and water are the products. This is called esterification. This ethyl ethanate is called an ester. And you can see, it is a reversible reaction, meaning that if ethyl ethanate is hydrolyzed, it will give us back the ethanol and the acid, ethanoic acid. Esterification is a type of neutralization reaction in the sense that salt and water are formed. Those salt and water are the products of neutralization reaction. They are also the product of esterification, telling us esterification is a type of neutralization reaction. Reaction between an acid and a base. The ethanol is acting as a base here. For us to get salt, which is ester, and water as the product. Yes, we've taken care of ethyl ethanate. Ethanol going to chloroethane. Ethanol going to chloroethane. Now, you will permit me to explain this. C2H5 again, OH, okay, plus Cl2. For us to have C2H5 Cl, that is a chloroethane, plus, okay, he said, help me check that question, to chloroethane, is it?
Chloroethane.
Okay, to chloroethane, this is chloroethane. If you look at this reaction, hydrogen is displaced. Hydrogen is displaced from the alcohol, from this alcohol. And this is simply substitution reaction or displacement reaction or replacement reaction. Now you see chlorine atom replaces hydrogen. That is it. Substitution. This is substitution. Substitution reaction. The next one is it is giving us a ethoxide. When you have ethoxide, and this one, we get this when this one reacts with a metal. When this one reacts with a metal like sodium, ethanol, to give us sodium ethoxide, C2H5ONA. This is an ethoxide, plus hydrogen. Hydrogen is liberated. Which type of reaction is this? This is also replacement, displacement reaction, in which sodium, which is high as we like. The next one is ethanol to ethanoic acid. Ethanol undergoes successive oxidation to become ethanoic acid at the end of the day. The oxidation is not a step process. It involves two stages. It is not a stage. Ethanol C2H5OH will become an aldehyde, an alkana. You are familiar with the alkana. Let me use alkana. It will become an alkana, CH3CHO. This is a ethanol. 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 Why complete oxidation will give us ethanoic acid, CH3COOH. Can you see oxygen is being added? If you look at this, compared with this, hydrogen is reduced in number. Removal of hydrogen from a substance is oxidation. Oxidation has taken place like that. What is the source of the oxygen? Oxidizing agents like potassium heptaoxodichromate 6. That's K2Cr2O7. This is the source of the oxygen. Oxidizing this to first become ethanol and finally become ethanoic acid. Ethanoic acid. From my explanation, you should know this one is oxidation. The name of the process is called oxidation. With this. The next, please.
We have to consider the following compounds.
Okay, I need to write. Consider, we have to consider this. Okay? This, we have to consider this. Okay? We have to consider what is on the board. Then the questions on it.
The first question is that we should write its IUPAC name.
Okay, what is the IUPAC name of this? IUPAC name. The name given by the International Union of Pure and Applied Chemists. If you look at this, identify the family it belongs. It belongs to alkanol. Alkanol. Because of what? Because of the functional. Sorry, I stand to be corrected. This is not an alkanol. Here, I considered only this OH. This O is part. This is it belongs to oic family, to acid family, alkanoic. This is alkanoic. Alkanoic. Okay, as this is alkanoic, you will count the number of carbons that are here. 1, 2, 3, 4. That is 1, 2, 3, 4. Normally, the fourth member in the series is butanoic acid. But you will not just count like that because we have a branch. This one is not a straight chain. It's not continuous with this structure. It's a branch. This is an appendage to this. You consider this one as a substituent. Having identified the functional group, and we also have seen the substituent, which is methyl. The substituent is methyl. We can now name. How do we name? We name from the end closest to the functional group. This is the end to the functional group. I now consider this one carbon 1. This is a carbon 1, 2, 3. What I have is propanoic acid. This is propanoic acid. Propanoic acid. But don't forget the appendage. What is the appendage? Methyl. What is the position of the methyl in the chain? Second position, carbon 2. It is now 2-methyl propanoic acid. This is 2-methyl propanoic acid. As simple as that. The functional group oic. The attachments methyl. It may be ethyl, propyl, butyl, etc. What is the position of the substituent carbon 2 methyl propanoic acid. Next question.
Give its molecular formula and empirical formula.
Its molecular formula and its empirical formula. Empirical formula is the simplest formula of a compound, while the molecular formula gives the actual formula of that compound. Meaning that anything we can get out of this will serve as the molecular formula. So my colleague will join me in counting the carbon. The number we want to count. One, two, three, four. 4 carbons. I write it down. C4. C4. The first credit. The next hydrogen. 1, 2, 3, 4, 5, 6, 7, 8. H8. The last is oxygen. 1, 2. Just 2 oxygen. This is the molecular formula. Molecular formula. The actual formula of that compound. Now, molecular empirical. Empirical, we just take this to the simplest ratio. We have 4, 8, 2. Empirical, we now do 2 is the smallest number here. Let's divide 2 by 2. 4 divided by 2 is 2. I have 2 carbons, C2. 8 divided by 2, 4 hydrogen, this divided by 2, O. This one is the empirical formula. The lowest possible formula of a compound. We move to the next question.
The next question is, list the product of its reaction with saturated Na2CO3 solution.
Well, the product of its reaction with saturated Na2CO3 solution. Na2CO3 solution. Okay, I want to rub off this. Now, the thing is C3. I have C3. I want to write it in compressed form. 1, 2, 3. Okay, I have C3. I have H 1, 2, 3, 4, 5, 6, 7. H7. H7. I did not count this carbon because it is part of the functional group. I did not count this carbon and the oxygen and the hydrogen there. I will now put it as COOH plus sodium carbonate, Na2CO3. What will be the product? We are going to have C3, H7, COO, Na. This is a sodium butanoate. Sodium butanoate. 1. This is 1. This is, we have 3 carbons here. This is another carbon. Butane is the fourth member. And the corresponding oic to it is butanoate. This one will now become sodium butanoate. Sodium butanoate. Sodium butanoate plus we have carbon 4 oxide and water. These are the products from this. Sodium butanoate, carbon 4 oxide and water. Now, this very acid can react with a base like sodium hydroxide. If it reacts with sodium hydroxide, it simply gives you sodium butanoate, and water, which is neutralization reaction. If it is this combining with, let me change it, or I will take my time. Just note that if it reacts with sodium hydroxide, you get sodium butanoate and water are formed. If it is a mere metal it reacts with, you get this sodium butanoate and hydrogen. Hydrogen is liberated like that. The next.
State with reason whether its boiling point will be higher or lower than that of the corresponding alkane.
Now we want to compare the boiling point of this with that of an alkane. The alkane that corresponds to this is butane, which is this. The boiling point is higher than that of the corresponding alkane. Why? It's because this has the tendency to form hydrogen bonding when in solution. Why? If you look at this one will not form any hydrogen bonding. We have hydrogen attached to this all through. Hydrogen attached to this all through. And hydrogen bonding is formed between an atom of hydrogen and a highly electronegative atom. Nothing like a no electronegative atom in the alkane. Why we have electronegative atom, which is oxygen here. You can now, hydrogen bonding is now observed in this. If you draw another molecule of this, you want to draw another of this, but I will orient it in order to form the hydrogen bonding. I will have it as C. If my functional group is here now, this is my functional group. This is OH. OH. This is my O. My O. Then this one, let me just put R here. The R represents all other things here. This is an alkyl group. When you see hydrogen and carbon combined together, it's no other one. If it is not an alkane, an alkyl is one hydrogen deficient from the corresponding alkane. I will just put it as R. This is the functional group that I need. If you look at this, hydrogen bonding can be formed between oxygen, this oxygen and hydrogen. Because it's a bond formed between hydrogen and a highly electronegative atom. Oxygen is electronegative. If it is chlorine, it can form. If it is fluorine, fluorine also can form with this. This oxygen of this acid now can combine with the hydrogen here. Look at how well I orient them. I know the orientation they have so that it is between hydrogen and oxygen. Hydrogen and oxygen. It has higher boiling point than the corresponding alkane because it can form hydrogen bonding in solution. And hydrogen bonding is a strong bond. It is a strong bond. That is why it has higher boiling point. It requires more heat or a more elevated temperature to break hydrogen bonding. The next.
A vegetable oil X was treated with activated charcoal and then with a gas Y in the presence of a catalyst in order to manufacture manganese.
Okay.
Then the question, identify Y.
A vegetable oil
Yes.
was treated with a gas X or Y. With a gas. It was treated with activated charcoal
and then with a gas
and
Y.
with a gas Y
In the presence of a catalyst.
in the presence of a catalyst. And
in order to manufacture drink.
In order to manufacture my drink. Then what are the questions?
Identify why.
Identify why. The gas is hydrogen. The process in which that converts oil into margarine. Oil is a liquid fat. Margarine is a solid fat. That process is called harddening or hydrogenation. The gas, why is hydrogen? The next.
State the function of the activated charcoal.
Oh, the function of the activated charcoal is to remove color from the oil before it is hardened. Activated charcoal, we made mention of it in the earlier part of the class. Charcoal is also used in decolorizing or in bleaching a substance, removing color from it. It's to decolorize. Any other question on that?
What is the catalyst used?
What is the catalyst used in that reaction? The catalyst used is nickel. Is nickel. And students, I would like you to know catalyst in some other reactions too. Like in Haber process, manufacture of ammonia, the catalyst used there is finely divided iron. Contact process that we did, we were able to see that it is vanadium 5 oxide that catalyzes the reaction. We have so many, the extension that we pointed out the other time. H2SO4 is the catalyst for the reaction. We should know some reactions and the catalyst that age their progress. Next.
If a sample of X is heated when concentrated NaOH solution, list the products that will be obtained.
Okay. If the sample of X
is heated,
these my markers, they are faded. If it reacts with that X, with known X is oil. When oil reacts with sodium hydroxide, we are going to have salt, and the salt form is a soap. That is the method employed in the manufacture of soap. Because this local soap that they produce oil, they will get oil, they will get sodium hydroxide. The base, which is usually obtained from ash or ashes, that is how they produce soap. The products obtained are soap, and glycerol. Soap and glycerol. I will have shown the equation on the board. Soap and glycerol, which is propane 1,2,3-triol. These are the products formed. Next.
Number 6. Methane reacts with chlorine under certain conditions to produce tetrachloromethane. State the condition for this reaction.
Methane reacts with chlorine. This is methane, CH4. Methane is CH4. CH4 reacting with chlorine and to give us tetrachloromethane.
Yes.
First, this one involves successive chlorination, in which we are going to have monochloromethane. Then monochloromethane is chlorinated again to form dichloromethane, trichloromethane before we get to tetrachloromethane. The condition needed is sunlight or UV light, ultraviolet light, specifically of around 300 nanometers is ultraviolet light. That is the condition. The next.
Name the type of reaction.
Name the type of reaction. If we see, not that directly, please look at this my equation very well. CH4 plus Cl2 will give me CCl4. This is not going to be gotten directly. It is from, we are going to have monochloromethane, dichloromethane, trichloromethane, which is chloroform before we get to this. But this is the desired product. Now, the question asked, remind me,
Name the type of reaction.
the type of reaction is substitution. If you look at it, chlorine atom is substituting or is replacing hydrogen. And here you cannot see hydrogen again. It is chlorine you can see in place of hydrogen. This is substitution or displacement reaction. Go on.
The next question. Give two uses of methane.
Two uses of methane. Methane is a fuel. That's one. Methane is used in the manufacture of hydrogen. This successive chlorination, we are going to have, I said we are going to have trichloromethane before we have tetrachloromethane. Trichloromethane, which is chloroform, is an anesthetic agent. An agent used in sedating animals. This very one, this tetrachloromethane, is an important organic compound obtained from methane. Don't forget, it is as a result of substitution reaction between chlorine and methane. And we are asked the uses of methane as a fuel in the manufacture of some compounds, namely hydrogen and carbon dioxide, and some other ones. As well, its substituted derivative. Chloroform, which is trichloromethane, is an anesthetic agent. Tetrachloromethane, which is this, it is an organic solvent. Go on.
Name one major natural source of methane.
Natural source of methane. We can get this from a natural gas. When you are mining, you can get it from coal mines. Coal mines. When you are mining your coal, that is natural source. It is also obtained, gotten from a marshy habitat. When plant materials are decomposed, they are going to transform into methane. In such a case, that's why it is called marsh gas. Marsh, from a marsh. You know a marsh. You know a transition between a terrestrial and aquatic habitat in which a waterlogged place. These are places we can find methane. Go.
Mention one similarity between the reaction of ethanol with sodium and that of sodium with water.
Similarity.
That is
Similarity.
what they
How
have in common.
and likeness.
Yes.
What they have in common.
Yeah.
Reaction between
Reaction of ethanol with
Ethanol.
sodium. Ethanol with sodium
ethanol, sodium,
and that of sodium with water.
CH5OH and sodium, the reaction. Then reaction between sodium and water. Now the two reactions, if you look at this, I've shown on the board the other time that you are going to have the top side C2H5OH Na plus hydrogen here. Why for this one? You know, you are going to have a sodium hydroxide. You are going to have a base here. One thing, this is a sodium dissolving in water to give a base. This one also is more or less a base because sodium is a strong metal. Now, in essence, one similarity is that the two of them are alkaline. They are what? Alkaline. They have pH greater than 7. This is a base, an alkaline. Greater than 7. This one is also in nature. That's one. Another one is that when you see, I don't know if you have ever seen a reaction between sodium and cold water. You should not even try with hot water. It is explosive, a violent reaction. But violent, this one also, you said
Except sound.
This one, violent, explosive, even it can break the container in which it is taking place. Meaning that you are going to notice a fast essence of gas, a fast essence of gas. Gas will be liberated. Can you see hydrogen gas liberated? It will be liberated in the two. These are the 15 alkaline. The two are alkaline. You are going to notice a effervescence in the two reactions.
Um, Next question. Write the structure of two isomers of C3H8O.
The question says write
Structure
the structure of two isomers of this. If you permit me, I will just say this is CCC, H, 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 H. When you see that, I didn't put anything, H, H, H. Making 5, H, H. Then I will have OH here. If you are moving 1, 2, 3, 4, 5, 6, 7, I have one net,
yes.
which is part of this OH group. Guys, I can identify this one as an alkanol. This is an alkanol. And the structure, when you put hydrogen around this one is propan 1 or propanol, or simply propanol. Propan 1 or propanol, because hydroxyl group is located on the first carbon. Are you following? Another isomer that could be obtained from this is that you can have it C and change the position of the hydroxyl group. When it is changed to the second carbon, we have OH here. We have OH here, then all this one will become HHH. This is propan 2O. This one becomes propan 2O. We are asked to give two isomers. Propan 2O. Propan 2O. Another isomer that is possible here and is this. Let me just write the compressed formula. Maybe you can make sense with it. CH2, I have 3 hydrogen. Okay, CH2, CH3. Okay, sorry. My carbons are 4 here. 8 hydrogen, 5, 8. For 3 carbons. 3 carbons. Yeah. And let's leave this. I think it's not coming out well. But these are the 2 basic ones.
Differentiate between a fine chemical and a heavy chemical.
And
Heavy chemical.
heavy, fine, and heavy. The basic difference between them is that those chemicals manufactured in large quantities because of their needs. Because of their needs are called heavy chemicals. Those ones manufactured in small quantity because of their limited applications, they are referred to as fine chemicals. Fine. These fine chemicals, they are manufactured to a very high degree of purity. They are always pure, like drugs. The drugs are very, very pure, like drugs. Why heavy chemicals, dyes, drugs, they are fine chemicals. Why this? What is H2SO4 that you are familiar with? It has so many industrial applications. It can be used as a dehydrating agent, as a drying agent, as a catalyst in petroleum refining. So many. Likewise, sodium hydroxide is a heavy chemical because of what? It has many uses. Did you get it? Fine, they are required in limited quantity and they are very pure. Very pure. Dyes and drugs. Dyes that we use in the lab, the indicators. Why the heavy, those chemicals that we need, ammonium nitrate, name them, they are heavy chemicals. Can we move to the next question?
This one is calculation.
Calculation. Okay. Is that the last question?
We're almost done. After this, we have like 2 more.
Okay. Move on.
Two compounds, X and Y, have the same percentage composition.
X, Y. Okay. The same percentage composition.
Composition by a mass of 92.2% carbon and
92.3%.
yes, of carbon and 7.7% hydrogen.
Okay.
Calculate the one empirical formula of X and Y.
Okay. Okay. The empirical. Let's take care of the empirical first. These are their relative percentages. Okay, and the first step in calculating the empirical formula is to divide through by the atomic masses. The atomic mass of carbon is 12. That of hydrogen is 1. We'll do. Let's do for this one first. When we do 92 divided by 12, 92 divided by 12, it's 4. That's 4 points what? And not maybe I need to resort to a material because of the calculation. 92.3 divided by 12. It will give us 7.7. 7.7. Why this one gives 7.7? 1 divided by this. Next is to divide through by the smallest. The smallest is 7.7. 7.7. Then we have 1 as this. The empirical formula of this is simply CH. Because 1 carbon, 1 hydrogen, CH. For this one also, we don't need to express ourselves. It goes the normal way with this, divided by this, then we have this. Empirical, we are going to have CH for the 2. It is the molecular formulas that will differentiate them. You do for the second one, which is by these steps. Then the next question.
Next question is we have to calculate the molecular formula of each compound.
Molecular formula of each compound.
If molar mass of X is 26 grams.
Molar mass of X.
Yes, it's 26 grams.
Okay, 26 grams.
And that of Y is 78 grams.
That of Y is 78 grams.
Yes.
Good. Don't forget, we have arrived at the empirical formula. Let's clean this. We are going to molecular. Molecular formula cash. Molecular formula is equal to empirical. Sorry. It's equal to, we'll just manage it.
Yes.
The molecular formula we want to calculate now. And then we have the empirical formula, which is the CH. We are now going to say CH bracket N, which is unknown, is equal to the molar mass of X, which is 26. The molar mass of X, which is 26, And the atomic mass of carbon is 12. We have 12 plus 1 hydrogen. N is equal to 26. Then here we have 13N is equal to 26. From here, our N is equal to 2. We divide 2 by 13. Our N is equal to 2. The molecular formula now becomes is now equal to bracket CHN, which is our N now is 2. For X, the molecular formula of X is equal to C2H2. C2H2 and C2H2, this is ethane. This is ethane gas. C2H2. You follow this step, put in bracket the empirical formula N, then the atomic masses, add them together is equal to the molar mass. Then you find this. This is for X. For Y now, the two share the same empirical formula, simply CH for this one also. Since we have CH for this, then bracket N is equal to 78. Let's go by the same way. 12 plus 1 that is equal to 78. 13N is equal to 78. Divide 2 by 13. N from here, how many 13 in 70? In 78. 13 in 78, that should be 6. That should be 6. That is 6. Our molecular formula now is equal to CN CH bracket N CH bracket N, which is now 6. We now have 6 C6H6, which is benzene. One is ethane, the other one is benzene, but they share the same empirical formula. Is there any other question left?
Yes.
Let's quickly endure for 2 or 3 minutes.
A protein is boiled for a long time with dilute HCl and reaction occurred. State the types of reaction that occurred. When
protein reacts with acid, the acid hydrolyzes the protein. The reaction is called hydrolysis. The next question, hydrolysis.
Name the major products formed.
The major products formed are amino acids. The breakdown product of proteins are amino acids. Then the next.
Give the functional groups present
in amino acids. Yes. I would like to illustrate that quickly. In amino acid, we have alkyl group, R group. We have this group. We have NH3 group. Then we have carboxylate group. This is an amino acid. Then we have hydrogen. This is an amino acid. You can see 4 different groups attached. This is an alkyl group, hydrogen, carboxylate, ammonia. The major groups there are this, which is we have amino group NH2. In this one, this is the ionized form, but if it is not ionized, we have amino NH2 amino group. Then we have carboxyl group. These are the groups present in the compound, which is protein, amino and carboxyl group. With this, we've come to the end of the lesson.